So I thought I'd start with a preamble because it will make sense to people who might watch the video, and I know that I'm speaking to the converted already, but we're here at FOSDEM because we know that over millions of years evolution has made humanity exceptionally good at sharing. And make sure it's green. Yeah, so we've been here, we know that humanity is exceptionally good at sharing. So good that all humans do it, not just with our own offspring, but with extended family and with friends and even with strangers. But in a world full of predators and parasites, sharing was only possible because nature found ways to enforce reciprocity. And if you believe in the tragedy of the commons, then sharing comes with risks. Although humans have evolved to be generous to one another, there are constraints upon who can share, upon who you can share with, and how generous you can be, at least without being exploited by those, or losing out to those who are happy to take and they won't share back. And honestly, sometimes that's everyone. Sustainable sharing is hard. Whenever there is a risk that trust may break down, and whenever others can free ride or defect with no real risk to themselves. It's all a matter of incentives. What are the payoffs, and what are for the various actors, and how do their incentives influence their behavior? An effective solution from history was for a sovereign or a strong man to enforce private property and exclude others who might otherwise free ride. An effective solution from, I'll put the same words in twice, sorry about that. But if we keep sharing while those who benefit from what we share don't share back, then at some point they will outcompete us and everything will be enclosed. Now, we know that free software is both beautiful and powerful because it allows us to share while locking the value embedded in our software in the commons. And it does it by using the laws that were designed to preserve private property to preserve collective cooperation instead. Now, free software licenses help people outside the commercial market resist certain forms of extractive profit-taking and keep proprietary rent-seeking at bay to some extent. But free software hasn't been so successful. Free software has been so successful because we all care about freedom, and not only of ourselves, but the freedom of others. And free software licenses have helped us prevent selfish actors from capturing and closing the code base. So far, so good, but unfortunately, free software licenses do little to divert resources back to those who created the software and maintain the infrastructure. Running a Tor node, for example, costs 300 euros or so, and it takes the dedication and altruism of people who are prepared to share, even when there's no guarantee that the network itself will reward them. Much of the real financial value of many of our tools, both Libra and proprietary, turn out to be embedded in the network effects of the social behaviors of the people who use them, rather than in the software and the hardware itself. And in other words, the metadata is where the money is. Now, the financial success of Google, Facebook, and the other Web 2 giants has proved that how lucrative it is to exploit the vast monetary value that you and I create in our social interactions with one another on the web. Extracting our metadata and habits of behavior is what software as a service and Web 2 in general has been about. Our spending patterns and the other information we leak to the system has made it profitable for venture capitalists and big business to invest in systems of user surveillance, demographic profiling, personalized advertising, and social control. And our behavior and our data has been so vulnerable to surveillance and so open to influence, in large part because of the network infrastructure through which the information moves. And the server-client model was so successful because of the technical simplicity and good enough mentality that got the networks working in the first place. Our end-to-end encryption, while an important element in user security, does little to secure user sovereignty because it leaves the information and the social graph open to scrutiny. Of the social graphs open to scrutiny. When correlated with many fragments of identity, our social and financial interactions remain open to analysis and therefore are more vulnerable to undue influence. And the lesson of the Snowden revelations was not that they are watching you, but that when it comes to data security, the admin is king. In the walled garden of Facebook, Twitter, or whoever, the cats, yeah, as cats might say, all of your database belong to us. So given that the Facebook, Twitter, Google and the rest only appear to offer their users a free lunch, while in reality those who operate the service make the people who use it pay with their attention, their free will, and the exploitation of their social relations, this has come about by a combination of economic selection, information asymmetry, emergent properties, chance, and deliberate design. Web 3 is the cutting edge of attempts to address these problems in a truly meritocratic, democratic, and egalitarian way. Now, who here has heard of Ethereum or has used it? That's a pretty good proportion, but some of you haven't, and Ethereum itself aspires to be the world computer, distributed across tens of thousands of nodes, which collectively contribute to the security and availability of the network. Ethereum is made up of three core elements: the EVM, which is the virtual machine, and it reads and writes from the distributed and decentralized deterministic data structure that most people just call the blockchain. And Whisper is the unrouted ephemeral signaling layer of Ethereum, in which data payloads are small, they have a limited time to live, and are repeatedly forwarded throughout the network until they expire. The unrooted nature of the Whisper protocol provides very strong security and anonymity, but that security and anonymity comes at the cost of reduced efficiency, i.e. latency and receipt indeterminacy. Then there's the swarm element of the Ethereum stack, which is a rooted network protocol that holds the decentralized persistent storage for Ethereum and is aiming to provide base layer services for Web 3, the decentralized web. To do this, the Swarm team are implementing file storage, decentralized database services, and PSS, which is Postal Service over Swarm. Now, Ethereum as a whole is being designed and developed to solve the problems of balancing the incentives I was talking about in the beginning in a free and open system. Ideally, within the Ethereum ecosystem, there's no concept of a client-server model. All participants in the network are peers, and each full node is incentivized to participate in the system. But having said that, not all nodes are created equal. If you want to run Ethereum from your mobile phone or from some other resource-constrained device, then you may prefer to call upon the network more than contribute to it, which is where the economic incentives of the system come in, the crypto economics. Now, the incentive structures of the Ethereum ecosystem, either Ether itself or the numerous other tokens like the Status Network token, SNT, are being designed to incentivize cooperation and make parasitism costly. I described mobiles as resource-constrained devices, but mobile computation is fast becoming the dominant form of computing as the desktop computer becomes less popular and wireless network connects more and more of the globe. So Whisper provides full obscurity of recipients because information is continuously relayed by those who for whom it is intended. Now, Whisper nodes also transmit dummy information like chaff, which means that the transmission schedule is provides less information for data traffic analysis. And a recipient is anyone who is able to decrypt the information that they are able to access. So a recipient is anyone who has a decryption key and is able to access the data in a blob. So there may be one or many recipients for each bit of information. This makes traffic analysis extremely challenging because from the outside it's impossible to determine when or whether a message has been received by any or all of its intended recipients. But destination is not the only information that an observer of the network could use to determine what is being communicated. As with the cracking of the Enigma cipher in the Second World War, it's sometimes possible to determine the contents of messages by their length or their shape. For this reason, Whisper also implements message padding, and all transmission are of a standard set of sizes. Now, Swarm is sort of the network of nodes which stores the chunks of data throughout, without trusting the nodes that are storing that data. The address of each chunk of data on Swarm is the hash of the data in that chunk. So when sending messages over PSS, which is the postal service over Swarm, instead of using the address of the hash of the message, the sender adds the desired address to the beginning of the message. And then the node forwards messages to their peer with the most bits similar to the beginning of the address. So all of the nodes compare the first part of the message to determine where to send them. So the less address information, the more widely the message will be sent out. Now PSS uses Whisper's enveloping structure for everything except the address field. So every PSS message has more or less specific address, or none at all if you just broadcast it widely. It has an expiry time, a topic, a payload of fixed size, which is an encrypted blob of data plus padding. And that encryption can be either symmetric or public key encryption. And Status is the mobile version of Ethereum, so that you can run it on Android or iOS at the moment, and there should be a desktop implementation as well. And the nodes in the Status system are relying on other people to provide the heavy lifting part of the service because they're resource-constrained devices. And in order to reward those who, rather than having like the Tor system where the servers are provided by the altruism of those who are actually interested in the freedom of all the users, there is also the embedded economic reward of using the token structure to run a node which will pay for its own electricity at the very minimum, or and provide you with forwarding services for when you're offline, when your phone's not available, for example, so push notifications and sort of message holding when you're off the network. And as I said, I have run out of the rest of my pre-prepared thoughts. So if anybody has anything they'd like to ask about RTC over Swarm or decentralized communication. Hello.
Is there a timeline when Whisper, for example, will be like enabled by default?
So but what was the last bit?
Like in the Get client or something?
I don't know what so the Ethereum node itself, you don't have to have the Whisper. I don't know. I give up on that one. It's fallen off my brain. Yeah.
How are they managed? If I'm saying Daniel, who else can play Daniel, and how the other identify the right Daniel?
So yeah, as far as your own private keys are concerned, so the key management systems are hard in general. So inside Ethereum itself, inside Status itself, there's integration with ENS, so the Ethereum name service, which is effectively a linked list between identities and private keys. So you can register a private key and say, this is me. So you can register your name inside the system, and then you can send that through your contacts to other people on the in Status. Then in Ethereum in general, there are various different sub-projects that are aiming to solve the problem. So one of which is Uport. So that is a sort of a further down the stack contract layer that helps people distribute re-access information. So they'll be able to say, these people are the people I trust, and if I lose my key, I can get they can validate me with a new set of keys, and that'll be my new identity, and it will create a consistent identity across multiple keys. Well, so yeah, reputation again is another element. So the base layer you can keep building on top of.
How long this whisper messages out their system?
Ah, right. Okay, so the Whisper itself has no incentive built into it. Whisper is just a forwarding system. But in order to have some form of spam prevention, the more that you encrypt, so take the metaphor of an origami message. So you get your message, you write it on your piece of paper, and you fold it into an origami shape. Now, it's a crane. And outside, so that's your topic, is the shape in which you fold it, let's say. And there are people out in the network listening for various topics. So they're looking for a varying specificity of message topic. And as you fold the more elements or the more intricately you fold, in other words, compress your message, the more work you put into compressing your message, the longer you can expect that message to persist in the network. It also, you can give it a time to live specifically, but the more you compress it, the better. Now, if you've got a mobile phone, you don't want to spend a lot of time crunching that. So then again, it gives you an opportunity to delegate that to someone providing the service on the network. So you just say, rather than compressing it heavily, I'll send it to a more capable machine, and they can hold it for me until the recipient arrives. So you can just encrypt it to the minimum. And then inside Swarm, because Swarm is addressed, or more closely addressed. So Whisper doesn't bother with addressing at all. You just broadcast, and then it's forwarded and forwarded a number of times until that decay has happened, and it's effectively it fades away. Whereas with Swarm, the more you still have an address, you now have an addressing system, which is done on the parity of the bits at the beginning of the address. So if you have a set of nodes which start with 111 and your message is 110, you will send to some of those addresses. But if your message is 000, it won't go to any of those addresses. And then the closer to the target it gets, the more it propagates. So it's harder to decide who was the final recipient who had that last bit of key. And if I receive a message, and I have the decryption key, I get the message, I can read it, but I'd still forward it because no one else can read it, or at least, probably. There may well be other people who can read it, and so it's very hard to determine whether that message landed at the recipient, and so on. Hello.
On that slide, it says that you can chat and browse.
Right, okay, so this is status itself. So status itself is attempting to create an OS, if you like, for Ethereum from a mobile. So inside status, you'll be able to access an Ethereum contract as if you were on a more robust machine. Effectively, when you have status on your phone, you have a node, an Ethereum node. It's not a full node. You've got the light client, so you don't have the entire history, but you have snapshots and headers that give you enough security to be good enough. And then that means that you can now use the browser element of status to interact directly with Ethereum natively on your phone.
Okay, so this means you can just browse contracts.
If you think of so Web3 is decentralized form of the web with a deterministic layer underneath. So you have distributed trust. You're interacting with a web app, but rather than it being hosted on a specific server that you trust, it is distributed across the network. And the contract that runs on Ethereum, or the interface through the Raiden network, gives you the functionality of the dApp without necessarily being It's not like a code level interaction with the contract. It's just you're browsing. It's like you don't interact with JavaScript, do you? Well, you do, but you have a user experience of it. So, cool.
All right, I think that's all the time we have for questions.
That's great. Thanks.
If you have any more questions, feel free to meet him in the back. Yeah.
Cheers.